Amazing. Okay, thank you. Okay, we can start now. Yes, so this is going to be about Trane, which is a kind of live coding DSL written in this kind of lispy language called Janet. So yes, it's a sort of music playground as well. So you can play around with different sounds and sound designs. And it has module visualization, so you can see what's kind of happening when you run your codes, and twistable knobs, so you can easily kind of tweak the sound.
One more tick, please.
I don't know if we can hear this. Let's see if the sound. Yeah.
So which one are we using?
It should be this one, this HDMI.
And what's the volume set at right now?
Full, it should be.
Well, that's not full. That's grayed out.
It's,
There is no audio that is registered to that device. So sorry to interrupt the talk with
It's
this.
okay.
So that's not going to work.
we could play it through the speakers. I think they're quite loud.
They are quite loud. The trouble is about a third of our audience is across the internet. We could point the mic at it. Let's do that.
Let's do that. Okay. Let's see if this works for you.
You're muted now.
So I think you can hear that. Hopefully, yes? Okay. So we can kind of see that this is a sort of sample which we've loaded. This is its waveform. You can twist these knobs to kind of adjust the gain. Yeah, so if we maybe want to get rid of something, we can just delete this reverb. Oh no, I've got something connected to that. Let's maybe just delete this delay. And then we don't have a delay anymore. I don't know if you can hear that. Let's add it back in. And then adjust its feedback. So yeah, that's kind of the idea. Thank you. Yeah, so it's written in this kind of Lisp-like language called Janet. It's a really nice one. It's about 1 megabyte, and you can embed it in a browser by compiling it to WASM. There were some graphics playgrounds made by this guy called Ian Henry, and he also wrote them in Janet as well. And I really loved them. I'll show you one of them now, because I think they're really nice. So this is Toodle.studio. I'll again make this bigger. But on the left here, you've got some kind of Janet codes, and it's controlling turtle graphics. So if you remember those, I learnt some of it in school. And I really loved all of these. There's some good examples here as well. And so I decided to basically take the best bits of Sonic Pi, which I liked, and some of this, and just mash them together. So when we're kind of writing Trane programs, you can think about them in kind of two halves. On the left half here, I've got this kind of syntax for creating modules. So these are things which create sound. So I've got a synthesizer called Hello Synth here, and that's plugged into a reverb, and then that's plugged into the kind of main output. And this chain thing kind of chains things together. So it takes the kind of output of this first form here and plugs it into the input of this one, and then the output of this into the input of this. It's just like an effects chain, like that. So that's one half of the language. And then the second half of the language is, well, okay, we've got this kind of, these modules sitting somewhere, and they're all plugged into each other. But how do we actually make music on them? And so you can do that from these things called live loops, which, again, I've just stolen from Sonic Pi. And they're like regular kind of while true loops, but they run in their own thread. And they have some kind of internal clock. So when you're calling this play function here, which plays a note on a synthesizer on this Hello Synth that we've created over here, it's going to play that at the live loop's own internal clock time, basically. It's got this local time variable. And when you call sleep, that just advances the time variable by that amount. Is this all making sense? Great, okay. So yes, we kind of saw earlier that modules have to have a name, and that's because we want to send them events later, so kind of parameter changes or play events. And after you've created a module by just wrapping its definition in some parentheses, you then can refer to it by its name. So if you want to do extra wiring on that later, you can just use its name. Okay. You can kind of wire these together to create different sounds. We saw a bit of that earlier. And wrong wiring, where the compiler can kind of work it out. If it knows it's definitely wrong, like there's something which exists and you plugged it into the wrong thing, it will shout at you. Let's have a look at that. So here's another example. Here I've created this LFO. It's a low-frequency oscillator. It's just an oscillator which is kind of oscillating at like generally below audible frequency. And then here I've got this actual audible range oscillator called Oscar. It's plugged into an oscilloscope called Oscilloscope, and then that's all plugged into the output. And so if I run this, that's very loud. I'll turn it down. You can kind of see, yeah, I've got an oscillator. I can change its frequency like that, which is very fun. And then this LFO is just sitting there. It's not connected to anything. So I can use this other kind of wiring primitive here called wire. And this will wire the output of modulator, so it's this thing, this LFO, into Oscar's frequency. So Oscar's got a frequency knob here, and I can instead of doing this manually, I can just get the code to do it for me. So I'll turn this up again, and then fiddle about with these. And you can kind of see, maybe let's change the, yeah, so we're kind of doing some frequency modulation stuff there. So this LFO is kind of just modulating the frequency on that oscillator. And if we instead like change one of these names to the wrong thing, this is going to say, there's no thing called modulato, what are you talking about? And it will say, that's wrong. And it won't let you run that code. And that's kind of to stop these sorts of errors happening during performance. I've definitely had situations where I've kind of not heard any sound, and I'm kind of struggling to work out what's wrong. So that's designed to help make those better. Okay, so we've now learnt about some wiring stuff, and if we want to actually play notes on things, like I said before, you have to do it from a live loop. And yeah, they're like while true loops basically, but they run in their own thread. They have to have a name as well, so this one's called player, or like drum player. And Yeah, you can have kind of as many of them as you want, and they should all run kind of concurrently. So this live loop will play the note C1, which is a very low C note on a piano, and it will play that on the Hello Synth kind of module with a duration of 1 beat. So the kind of unit of time in Trane is the beat. And this will sleep for 1 beat, and then it will play a C2, an octave higher, and then it will sleep for a beat again, and then it will go back to the starts and do that forever. And if you change anything inside of a live loop, the next time it runs, it will play the new code. Yeah. Okay. How are we doing for time? We're great. Okay, thank you. So we can also change, instead of playing things, you can also change parameters, so the module knobs at specific times from a live loop. So let's see an example of that. If we run this, sorry, that's very loud again. You can kind of see, we've got this oscillator, and it's plugged into a scope, and it's plugged into the output. And I've got a live loop here, which is periodically changing the frequency, Oscar's frequency, this thing here, from 500 to 100. Yeah, so that's what it does. You can change these things, so let's change that to a 200. And then, oops. Yeah, it's live coding. You can do it all live. Okay, I hope this is all making sense. Oh, there were some other things as well, actually. Instead of thank you. You've got a few other options here. So this one's called lin. So that will linearly approach the value you want. Except this isn't working for some reason. Let's have a look at that. This could be a bug. Oh, there we go. So we're kind of linearly going between one or the other, which sounds strange. Okay, thank you. Okay, you've got some regular harmonic stuff like chords and scales, and in Trane they're generator functions. So you ask a kind of language to give you a scale in a particular key and type, like a C major scale, and then it will return you a function, and then the function, you can kind of use it as an index. So if you want the first note of the scale, you just call the function with 0, and so on. So we can have a look at that. So this one's just thank you, sorry. So this one's kind of just using this scale generator here, which is a C major scale, starting on a C4, which is like the middle notes on the piano, I think. And you can change it to a minor scale if you want, which is just a natural minor or a melodic minor. Or what else can you use? You can use a chords generator, which I've also defined here. And you can index like backwards into them, of course. So if I do, this isn't Lisp. There we go. So it just goes the other way. Yeah, that's the idea. That's harmony. Thank you, May. Patterns. So writing all of these plays and sleeps can be like kind of verbose. So you can use patterns, which are like a kind of rubbish version of the ones you have in Tidal and Strudel, but they work in a kind of similar way. So let's have a look. So here I've created a drum kit, which has some Roland 909 kind of hits in, and they're plugged into a scope. And then I've got some live loops which play notes on that drum kit. So you've got this thing, and this is playing the 0th and the 5th sample of the drum kit. So it's the bass drum and the snare, kind of alternately. These like subdivides in time. So if you stick those in a tuple, and then that kind of divides in time. So yeah, the way you can think about this, you can create patterns with this P thing here, and then you give it a tuple of things you want to play, and then the last argument is the time you want them to play over, and it will return you a array of tuples like this. So it's a note and a duration, and you can use those to sequence with. Yeah, that's the basic idea. You can instead, there's like Euclidean stuff in here as well, so you can replace this with, I think it's called Euclid. 3, to do the 1, 3, 8. So this means I want to play like this Euclidean rhythm, which is kind of trying to space out some hits over a number of sort of beats. And this is going to play the 0th note 3 times over 8 beats. You've got the hi-hat playing as well, but let's get rid of that. So that's... Sorry? An E. Oh, yes, you are, yes. It's yes. Yes, it's like a capital U. Yeah. There is an internal Euclid with the correct spelling. Yeah. Thank you. You've got some random functions as well in there. So pick 1, 2, or 3. It picks between its arguments. Rep repeats the first thing by the second thing's number of times. So rep 1, 5 gives you 5 ones. And so if you want to choose this kind of custom distribution of numbers to pick randomly from, you can do it like this. You can repeat 1 5 times and expand it into the arguments. So that's what the semicolon operator does. Yeah, there's probably a nicer way of doing this, but it seems to work well enough for me. There's seeding randomness as well, so you can set the seed of a random number generator if you want to perhaps experiment with random generation but have things kind of repeat in this kind of predictable way. Or if you send a track to another person, they can hopefully hear the same thing as you as well. Syncing live loops. So you can have as many live loops as you want, and they kind of all exist in this virtual time. But if you start one and you create another one, they don't necessarily have to kind of start at the same time or play over the same time. But if you want them to, the way you can do that is with this till measure length. And till measure length, if you call it, say here from loop A, this is it's kind of virtual time, it will return to you the length of time until the start of the next measure of that length. So if we have a 64-bar measure, so this whole thing, loop A starts here, and the first thing it does is it calls sleep until the next 64-bar measure, and it will sleep till here. And then it knows it will always kind of evaluate over a 64-bar beat, sorry, I should have said beat, kind of length. And so by doing that, you can kind of keep these things in time. Yeah. I think, yes, I'll leave some time for some questions and stuff. Yes, you can have a look at you can play around with it here at lisp.trane.studio. The code is all here under AGPL. And yeah, there's some example tracks here if you want to have a play around as well. And there's also some useful links here. So this Janet guide is a really good Janet book. It's all free, so you can learn Janet that way. And then the Sonic Pi website is kind of what the language is kind of based on. So you can have a look at that. Yes, I think that's it. Thank you.
We have time for a couple of quick questions.
Thanks for the talk. I wanted to ask about your motivation for creating this tool and whether how do you see it as different from other live coding languages, I guess?
Yes, it was born out of the desire to have, I guess, more control over the sound that I was making. Yeah, you can kind of create your own synths in SonicPy and other languages as well, but it tends to be not the most simple process. And I kind of wanted something you could instantly kind of tweak around with the sound a bit more. So it was kind of that. And also, being on the web, it's nice to be able to share links with people. That doesn't exist yet, but yes, that's kind of the main motivating things. Yeah.
Hi, that was really cool. I was wondering, so you've presented us a Lisp thing. I've seen SonicPy before, but this is Lisp. Do you have macros in this language?
You do. You can define your own and kind of play with the language a bit. Yeah, it's all completely up to you. So some of the things you saw were implemented as macros. Yes, don't look at how I wrote them. They're all horrible.
As most macros end up being.
Thank you.
So we'll take any future questions offline. Let's thank the speaker again.